Garment refitting is hard across avatars with different shapes, proportions, and meshes. Most authoring tools rely on a cage-based workflow, where users must manually build tight cages for both avatars, which is slow and error-prone. They typically resimulate the same sewing patterns on the target avatar, which often breaks the intended fit style. For example, a shearing dress on a smaller body may become too long and drag on the floor. Here we present LoBoFit, a new garment refitting method that can reliably fit a garment to target avatars with different body shapes, while still preserving the original design details and realistic, fine-scale wrinkles. We first introduce a new representation for garment geometry, local bone mapping blending. In this representation, we map each garment vertex into bone local coordinates with respect to its influencing bones. We can then reconstruct the garment by blending the corresponding inverse mappings in the target skeleton. We further introduce LoBoFit for garment refitting. It first initializes the garment on the target avatar using the target bones while preserving the semantic garment body correspondences. We then iteratively refine bone local residuals and blending weights to output a clean garment that conforms to the target body while preserving the intended fit and fine wrinkles. Our method has two key advantages. First, the equivariance of our representation enables a stable initialization that keeps the garment attached to the right bones, even when skeleton proportions vary significantly. Second, bone local optimization is better conditioned because it breaks refitting into localized subproblems, and soft blending across neighboring bones stabilizes convergence. Moreover, during optimization, our representation supports hierarchical, coarse-to-fine refinement, improving robustness and efficiency in challenging cases. The results show that LoBoFit robustly refits garments across diverse garments, avatars, and poses while preserving fine-scale wrinkles. Here, we show additional results across diverse garments, poses, and avatars. Even for this shearing dress, LoBoFit refits it to new avatars while preserving the designed shearing wrinkles. LoBoFit also extends naturally to multi-layer garments. We refit the layers one by one. After fitting the inner layer, we include it as part of the target geometry when optimizing the outer layer. Since LoBoFit is not restricted to a canonical pose, LoBoFit also supports dynamic refitting by processing simulated sequences frame by frame. Large body shape differences may cause temporal flickering. We leave physics-aware refinement for future work. Next, we benchmark LoBoFit against two state-of-the-art baselines. We compare our method with Marvelous Designer's refitting tool. Direct redraping often changes how the garment sits on the body, but our LoBoFit preserves the original correspondences, fit style, and fine wrinkles. We also compare our method with IFGR, a recent research approach for garment refitting. On garments authored in a canonical pose, LoBoFit better preserves the original design features during transfer. IFGR hard assigns vertices to their nearest bones, which can be semantically wrong under arbitrary poses and destabilize inflation. For example, the mouse ears get attached to the shoulder in a lateral raise pose and are pushed upward. To rule out head-related misalignment, we also run IFGR on the torso only. Even then, similar failures still occur. For instance, when the arm bone becomes closer to the abdomen than the spine. In contrast, LoBoFit maintains pose-consistent bone attachments, yielding stable initialization and efficient optimization. During optimization, LoBoFit balances feature preservation and intersection resolution, so some penetrations may remain when these objectives conflict. Physics-aware collision handling could further address these issues. Thank you.